Thank you very much, Nick. It's a very gracious introduction, and you make me feel welcome, and you say it confer really the honor on me of making me a distinguished lecturer here. But it's really just an honor for me to be here. I think I'm, in a sense, at the center of the world in the field that is my primary field of risk perception and risk communication, the work that's actually, I knew this was true because I stepped off of the bus when I got here and I saw, no, I didn't see that. Oh. Well, I saw this. It was very impressive. But then, what do I need to do to go to my, well, I'm afraid of technology. Well, this was an example, you see, of the risk. There's risk communication. This is one of your works, I assume, Nick. It says here that more people die each year from falling coconuts than sharks, right? And in most places, people don't realize this. And here, obviously, in Cardiff, because of Nick's work with the Risk Studies Center, there's an effort to communicate risk to people. And so this is quite special. But it is tremendously special to be here because there's so many prominent scholars. Nick is one, and Lorraine Whitmarsh, Adam Corner, Walter Pertinga is here. People studying risk and risk communication, and to have them all in one place. And inside of a university that has such excellent programs in psychology. And this is really quite special. I thank you for letting me share my ideas with you. Now, I talked to much already without showing some data. So here's some. And this is just a scatter plot of a diverse, well, nationally representative sample of US adults. And they're asked, well, how serious do you think the risk of climate change is, or global warming is? And that's what's on the y-axis. The observations are colored so that the people who are concerned about risk, they're red or orange, and if you're less concerned, you're more blue or green. And along the x-axis here, people are arrayed according to their political outlooks, right? So they're more left-leaning if they're on the left, more right-leaning if they're on the right, and actually fit a scale by picking their answers to the question, what party do I identify, how strongly, liberal conservative ideology, and that they fit together, correlate pretty highly, as you would expect. And you can see like the pattern, that the kind of red, warm colors, one then running down to the right. So I mean, that's a really strong correlation. In fact, the responses to that question correlate, well, minus 0.65, as strongly with the measure of the right-left political outlook as the two items that form the right-left political outlook scale do. So really, I could just add that item to the scale, and it would just help me do an even better job in predicting how people feel about issues like abortion or health care or the death penalty, right? So this is really about as politicized as you can get. And now I'm probably not telling you anything you don't already know. And here's one, I'll tell you one thing about this question. It's really nice because as simple as it is, rate the risk on scale 0 to 7. It correlates about 0.9 with anything else you ask people about climate change. If they can understand it's about climate change and they know what the valence is. So, is the Earth heating up? Are humans causing it? Are bad things going to happen? Also, with wrong answers, like how will the sea level rise if the North Pole melts? Right? Actually, it won't, because that's just ice sitting in the water. If the South Arctic melts, well, then ice is falling into the water. But they have an attitude, right? Just that this is my position on climate change. And so you can just take that one item. It's pretty efficient. But this is their perceptions of risk, including these kinds of issues of fact. And you can see how polarized they are and whether global temperatures have been increasing in recent decades overwhelmingly. The half of the population that's more left says yes, and most of the people on the right say no, and a few who are moderate say yes, but it's not being caused by humans and so forth. Right? Now, this is the maybe something that you wouldn't have known, but if you measure the sample's science comprehension, you can have a scale that combines their substantive knowledge of science issues with various facets of critical reasoning that are essential to be able to make sense of empirical information. Well, it doesn't correlate. Well, it looks like it doesn't correlate, right? It's not the case that people are becoming more concerned about climate change or less, like maybe a little bit less as they become more comprehending of science. But that's actually really a misleading way to look at it, because the impact of science comprehension on the perception of the risk, it really depends on what your ideology is, you see. If you're more left-leaning, then you become more concerned. If you're more right-leaning, then you become less concerned about climate change, less likely to say that the Earth is heating up, that humans are causing it, that the polar ice caps are melting, and so forth, right? Now, polarization is increasing, conditional on that measure of science comprehension. And this is an instance of what I call a science communication problem. Right? By science communication problem, I mean the failure of compelling, widely accessible science to dispel, resolve bitter political controversy about facts to which that scientific evidence seems to speak in a fairly compelling way. Right? And that's just weird, right? I mean, of course, people with different values are going to disagree about things that involve values. It's not surprising that they're polarized on abortion, right, or Obamacare. But is the temperature of the Earth increasing or decreasing? That doesn't depend on whether you're Republican or Democrat. Why would this make a difference? This is one instance of this problem, right? Maybe the most conspicuous, but it's not alone. Right? And in fact, the beginning of a lot of the research that I'm going to talk about here was started in the 1970s, where there was this kind of conflict in the United States, also Europe, about nuclear power safety. Right? And there, what the scientists were pulling their hair out of, why is the public, right, not converging on our view that nuclear power isn't dangerous, it's safe in absolute terms, and safer than a lot of the other things they could be doing? They're saying that even then. Hans Bethe even said in 1970, well, keep pumping carbon into the atmosphere and eventually it's going to be global warming. I don't think he calculated it, but that was one of the things he said could happen. Right? The other contemporary instances of it, I mean, there's some dispute about genetically modified foods here, more, I guess, on the continent. Not really any in the United States on that issue, but we had a big controversy about the Hpv vaccine. Right? Same this pattern, right? And it's mysterious, like I say. And what explains it? What might we do about it? I've already shown you that one thing that might have been thought to explain it doesn't, which is that people just don't know enough science, right? I mean, I'm not sure why Republicans and Democrats would disagree if they didn't know enough science to understand these issues. Anyway, there's facts, right? Why wouldn't it just be random or noise? But in any case, if that were the issue, you would expect the members of these groups who are the most science comprehending to be converging, right? Not splitting apart. Right? So what's going on? And I'm gonna address that. I'm gonna advance the argument that we should understand the science communication problem, this kind of division over policy relevant facts that admit of scientific investigation to reflect a polluted science communication environment, right? That there are influences and dynamics that are interfering with the normal and normally reliable faculties that people use to discern what's known to science. Okay? And the polluted science communication environment is very bad. Right? Just as the polluted natural environment puts the risk of people in danger, well, a polluted science communication environment puts the well-being of a democracy in danger. It prevents them from engaging in the kind of deliberation that would connect their policy choices to the best available evidence, a lot of good evidence that they have in a society that has science knowledge, right? Okay, so I'm going to present this claim here in 4 parts. I'll start out with the cultural cognition thesis, a framework claim about the nature of the science communication problem as a reflection of a polluted science communication environment. Then some evidence, right? Then I'll basically offer you something that's in the nature of an interpretation, combining some descriptive but also normative claims about the nature of the evidence that I'm describing. And then, of course, time permitting, we'll talk about what the remedy is for all of this, okay? So start with the cultural cognition thesis. The idea of cultural cognition thesis is just the claim that people can be expected to form perceptions of risk and other kinds of policy relevant facts that reflect their membership in and commitment to certain kinds of important affinity groups, cultural groups important to their identity. Right? And cultural cognition in this sense is a species of a broader phenomenon called motivated reasoning. Right? So motivated reasoning refers to the tendency of people to process information, maybe evidence, empirical evidence, or logical arguments, right? Maybe even the impressions they're taking in with their own senses, what they're seeing, right? To some goal or interest that is unrelated to or independent of the truth. Right? A classic example in 1950s psychology study called "They Saw a Game." And in the study, they used college students. That is appropriate in this one. The college students were from 2 universities whose team had played in a football game, and the researchers said to the subjects, the students, there were some very controversial calls made by the referee. We want you to watch a film of the game and see if the referee got it right. So, of course, all the students from one school, Penn or something, said, what the heck, is he on the payroll of Dartmouth or something's really wrong here? And the Dartmouth students said, well, he must have been a Penn alum or something like that, right? This was motivated reasoning. The emotional stake that the students had in experiencing a kind of solidarity with their institution was actually affecting what they see, right? Or at least that's how it was understood, and there's been plenty of research on this in various kinds of settings. And so here, the cultural cognition thesis, right, as an account of the science communication problem, is that people are processing information of all description in a way that more reliably connects them to certain kinds of important affinity groups than to the truth, right? Now, what kinds of groups? Here, this pattern could be a consequence. It is, I think, of motivated reasoning, where the groups. Well, maybe they're political groups, right? Now, I'm a Republican, you're or just people have affinity groups that will correlate with these kinds of political outlooks, right? So the political outlooks are kind of indicators, things that with proxies for the kinds of affinity groups that people belong to, and so now they're fitting their understanding of the evidence on climate change to those groups, right? Now, what we use instead, though, ordinarily, of the political outlook measures is left-right. It is a framework. Nick was adverting to Mary Douglas's work. We get this from her. Cultural worldviews. For Mary Douglas, she characterizes people's essentially preferences about how society or other kinds of groups should be organized, right, along these 2 orthogonal dimensions, and they're pretty intuitive. Actually, they're kind of ubiquitous in the social sciences. And maybe they're genetic or something, like, because when we're fighting dinosaurs and stuff, it really helped to have this kind of 2x2. I don't know, but like on the one side, if you think that individuals should secure the conditions of their own well-being without any kind of assistance or interference from the collective, you're more individualistic, right? If you think, oh no, the collective entity should be securing the conditions of individual flourishing, and if individual interests get in the way, then the collective takes priority. You're more communitarian. If you think there ought to be lots of conspicuous social rankings, that's how authority should be designated, then you're more hierarchical. You think people shouldn't be able to tell other people what to do just based on who they are. Right? You're more egalitarian. And Mary Douglas's claim, Aaron Wildavsky, a co-author in the book Nick was referring to, was that we should expect people to form perceptions of risk that reflect their membership in different kinds of groups that subscribe to the worldviews formed by combinations of the values that are associated with this framework. So people who are more hierarchical and individualistic, they said, would tend to be skeptical about environmental risk. Why? Mary Douglas doesn't really have a mechanism, but they get something like this, that if people start to accept these claims, and they think mainly about nuclear power, that there's environmental risk from technology, that's going to create a kind of demand to regulate commerce and industry and markets. And these are activities that are important to people who have these kinds of outlooks, symbolically as much as materially. Right? Whereas the people who are more egalitarian, communitarian, they're already kind of morally suspicious of markets and commerce and industry. Those are the source of unjust social disparities. So they want to go around blaming those things for all kinds of hazards. Right? That was Mary Douglas's story. Now, you see, cultural cognition, we owe to Mary Douglas a certain conceptualization of what the nature, or at least the indicators of the kinds of group affinities we're saying motivates cognition when people are thinking about decision-relevant science, right? But we want to know what the mechanisms are, right? So we want to use the kinds of dynamics understood by social psychology and other disciplines that show how people make sense of information, right, and show how they could plausibly produce these kinds of patterns between people's group affinities, right, the membership in groups who hold these kinds of outlooks, and certain kinds of risk perceptions. Now, she was talking, and Wildavsky, about the environmental risk. There are lots of other things, we've looked at, other people have looked at in both surveys and experiments, right? Some of them are actually cut along that other, I guess, diagonal there, but there are all kinds of issues. Some are really quite bitter, right? But we're interested in what the mechanisms are here. So I'll give you some evidence, examples. We did a study where we were looking at scientific consensus, how people form their perceptions of scientific consensus. Now, this is obviously very central to the science communication problem. And another way to put the problem is, why doesn't scientific consensus quiet these kinds of disputes, right? And what we did was, we an experiment. We showed people, some scientists, clearly scientists, right? And we said, do you think that these people are experts in these particular areas, so know enough so that if somebody trying to figure out what the right answer was, they could learn something from reading a book by this person? And they're all scientists, like I said, and they all went, well, one went to a great university, the other went to two okay universities or something like that. That's in my contract. You got that at home. So they're all members of the National Academy of Sciences. That's almost as cool as being in the Royal Society. And you think people look at this, so are these people experts on these particular issues? And we picked those because we know that people who have these cultural outlooks, which we measure with attitudinal scales, are divided on the kinds of issues that we featured here, the climate change, nuclear waste disposal, also whether carrying a concealed weapon makes crime go up or go down, right? And essentially, we're showing them what someone might think is some evidence, right? Here's somebody who seems to know a lot. Is this somebody who you think can tell you something about these issues? And we don't say this to them, but on which we know you, and people like you and people like that are divided, right? And of course, we have an experimental component. We tell half the subjects that the featured scientist took the position we would characterize as high risk. Climate change, in the case of climate change, it's real, humans are causing it, bad things are going to happen, there's consensus. In the low risk condition, it's too early to say, the computer models are speculative, we need more information, Right? Similarly, a high risk to nuclear waste, so it's very dangerous to put them in deep geologic isolation. No, not dangerous at all. High risk for the guns, and people allowed to carry concealed weapons. They might be more violent or accidents to leave the guns at home sometimes, forget them. You know, or no, low risk, because if everybody is carrying a concealed weapon, or even if everybody, you don't know if everybody is, right? But you don't know who is, so you're kind of on your best behavior. You don't want to piss anybody off just in case they might be carrying the weapon. If you laugh, somebody really can't say because you're not from the United States. And I can kind of characterize your cultural outlook at that point. It's interesting. But then the answer to the question, is this person an expert, is strongly predicted by whether the scientist that the subject saw took the position that is the one that's predominant in that person's group or opposed to it. Right? So if you're a hierarchical individualist, or if you're egalitarian communitarian, well, let's go back to this. Much more likely, a 72 percentage point increase in likelihood relative to the hierarchical individualist to see the featured scientist as an expert if he says, oh, global warming is a high risk, right? And 31 percentage points more likely in the nuclear power, higher risk. 61% if he says, oh, concealed carry, that's going to cause crime to go up. And similarly big effect sizes for the hierarchical individualist, right? Now, this is like they saw a game, because we're showing people evidence, right? Here's something, or at least it's prospectively evidence. Some scientists are saying something, and it's on an issue now on which somebody would have a stake because their group is associated with this. And now what significance to give to the evidence? Do you see an expert here, somebody whose view is entitled to be given consideration or not? It depends on whether that answer will connect you or not with the group. Now, this is a model maybe of how people are figuring out what scientific consensus is. They don't go around counting scientists. They don't know who a climate scientist is. You say James Hansen, you think, oh yeah, he invented the Muppets. You know, he didn't have any opinion on climate change, did he? And you know, but they are going through life collecting evidence, hearing people talking about this and saying things, reading statements in the newspapers. And if people do in the world what our subjects are doing here, right, they're going to end up divided culturally on what scientific consensus is, right? You might ask them, well, you might ask what scientific consensus is on this, you know, and they'll kind of do a little, you know, mental inventory. Oh, every expert I can think of says this, right? Because you've excluded from the sample the ones who take the position that is contrary to the one from your group. Oh, that's not an expert on that, right? And in fact, that's what we find, that the members of these groups, they think that the position they hold is consistent with scientific consensus, right? Now, I'm telling you what the evidence is for the cultural cognition view, but I'm also trying to give you some evidence about alternatives, right? Well, one alternative, people don't know enough about science, they get confused or easily misled. No, people who know most about science are the most polarized. Another, some people hate science, those anti-science people. They don't want to do what scientists say. That's not it either. You're really weird in any of these groups, in the United States at least, if you go around saying, we should have policy that is not consistent with the best available scientific evidence. No one talks that way. They disagree about what the evidence is, probably because of a process like this. Another related explanation, one of the groups sure as heck knows a lot more about science than the other. They're more in touch with it. Well, another reason we picked these issues is that each one of them has been the subject of a National Academy of Sciences expert consensus report, right? And they're not actually a polling group, but it's a nice kind of reference point if you want to assess patterns like this. You see, each of these groups relative to the National Academy of Sciences report is wrong 2/3 of the time, essentially, right? The group that's right, the egalitarian communitarians, about the consensus on climate change, if we treat the report as representing what consensus is, they're wrong about it, at least according to the National Academy of Sciences, on the nuclear, right, and vice versa. They're both wrong about the guns. The National Academy of Sciences says not enough that you can't say, because the kinds of evidence we have, it's inconclusive. We have to use econometric models, and they can be specified in a variety of different ways, all of which are reasonable, but then generate different answers. So you can't say whether more guns, less crime, but these guys do, right? So if you want to believe that one of the explanation for the science communication problem is that one of these groups is more in touch with science than the other, you'd also have to believe that they're more in touch with what scientific consensus is than the National Academy of Sciences, right? Don't ask the National Academy of Sciences, ask whoever, an egalitarian communitarian. That's one possibility. Or the other possibility is don't ask either, because neither's very good at it. They're both conforming what they see, hear evidence around them of what scientists believe to the view that's consistent with the position in their group, right? Now, one thing they agree on, climate change, they both agree recent weather helps you decide what climate change has been, right? But you see, what predicts what they think recent weather has been is not the recent weather in their area, right? It's their cultural outlook. So if you're more egalitarian, communitarian, you think it's been hotter out recently. This is the finding in one of my collaborators, Hank Jenkins-Smith paper. He's a collaborator on the last one. You're hierarchical individuals, you think it's been cold, right? So on the days when I want my air conditioning is not working, I start saying to myself that the death penalty does deter murder. I start to feel colder. I mean, they're actually feeling, right? This is a kind of a sense impression. I give you a little bit, this isn't published. We're in Florida collecting information about how people make sense of risk as part of a field applied research in science communication relating to adaptation and other kinds of measures that the local areas can take in relation to climate change. Right? So just to show you, the United States here, I'm looking at it a little bit differently. You take on the y-axis now, that same kind of industrial strength risk perception measure 0 to 7, and I have these two overlaid histograms, right? One for the egalitarian communitarians and one for the hierarchical individualists, right? And it's kind of bimodal there, right? It's not a normal distribution, and the same pattern. It's the same data actually, and this is a replication of something that we found in an earlier study, that science literacy and various indicia of critical reasoning, they magnify rather than dissipate the polarization. That's what the United States looks like. What does Florida look like? Florida, if you don't know, is kind of on the frontier, of kind of the path for climate impact, right? You think you guys are babies, and you get flooded, one time every 50 years. Look, and this happens every week. It happens every year at least. In Florida, it's been happening since Ponce de Leon got there and didn't find the Fountain of Youth and decided for some reason to put Disneyland on top of a swamp, and path dependence being what it is, and now always dealing with water, right? But climate change, is that, now you see, they're not really any different. I don't know if you want to tell me, the means are different. I don't care. It's the variance that I'm interested in. There's no right answer here. This looks pretty polarized to me. Now, we did another thing. We looked at how many times people have been exposed to adverse climate events, right? How many times has your life been adversely affected by something having to do with extreme weather? How many times have you been evacuated from your residence? This is not that uncommon in Florida because of hurricanes. How many times has your property been flooded? Have you had damage to your property and so forth? Insurance, it's in there, but everybody's is up, so you can always throw it out if you wanted, right? And we want to say, well, does that have any bearing on whether you perceive climate change to be a risk, right? So now we look at how the number of adverse events that they've experienced is connected to their perception of climate change on that measure. How many predictions? I mean, was that flat? Because, yeah, but you see, you just know it's a trick question or something. Yeah, it's flat. But you know something? That was my trick question, the trick question. It's not flat. It goes up if you're an egalitarian communitarian, and it goes down if you're a hierarchical individualist. You see, it also interacts, not as dramatically, right? You know what happens? The hurricane comes down, smashes two people's houses. The one egalitarian communitarian, one hierarchical individualist. The egalitarian comes running out, he's mad. He says, look, I told you, the climate change. We didn't do anything. Now look what happened to my house. And the hierarchical individualist, what are you talking about? I told you if we had gay marriage, this was going to happen. Now you see it. But this is actually, responsive to another theory about the climate change. This is the idea, it's related to the knowledge deficit theory. I don't know if anybody ever believed that, but people believe this one, bounded rationality, right? The reason people don't recognize that climate change is as big a risk as it really is in the view of scientists, they don't think like scientists. Right? They form their assessments of risk in a kind of unconscious, rapid, intuitive, heuristic-driven fashion. As a result, they end up overestimating really dramatic, conspicuous risks like, terrorism. There's a plane sticking out of a building on fire. That gets your attention. Whereas that silly polar bear, who cares, right? And therefore, they overestimate the more sensational risk relative to the one that actually is of greater consequence, but that you would have to be able to understand empirical methods, which require you to think in a slower, more deliberate, analytical, dispassionate way, right? The scientists think slow, system 2, whereas the public system 1, and one of the predictions is, well, wait for a little more system 1 experience stuff to catch up, When you're underwater, maybe you'll notice, right? Well, actually, no. And it's actually, I shouldn't make fun of it. You can see, these are plausible hypotheses, right? But more things are plausible than are true. So you have to kind of investigate to see how these things work. And at least one reason to doubt that things could work this way, I mean, what I showed you here, you don't believe it when you see it. You see it when you believe it. How else could it be? Right? You can see your house is blown down, but you can't see the process that caused that. The significance of that is related to things that aren't observable, that you would have to use empirical methods, that you'd have to take somebody else's word on. Right? Once you believe it, you see it, but not otherwise. So what's going to make people believe it? Well, another strike against this theory, right, is the increased polarization conditional on people's science comprehension. Or we include in the science comprehension measures of the kind of reasoning dispositions that are associated with the slow, reflective, analytical system too, and they just magnify the perception of risk. I'll tell you, show quickly one more study like this. We just did this recently. And what we did, we said, well, we show people results from an experiment. We say, okay, scientists have come up with a new treatment for skin rash. Thank goodness. He's like taking care of these risks we face, a risk of acne. But sometimes people's skin rashes, they clear up by themselves. Sometimes too, the treatment makes things worse. So what you have to do is an experiment. You have to give the skin rash treatment to some people, see how many get better, how many get worse. Don't give it to some other people, see how many get better, see how many get worse. Then you can figure out if this is going to work. And so we say, did it work? Does getting skin cream make your rash get better or rash get worse? And you all can see the answer right away, right? That it's making it get worse. But most people won't get that. When they see a problem like this as a kind of heuristic, they say, well, how many people got better when they got the skin cream and how many more got better, right? But then there's some who are a little deeper thinker. They say, well, they say that and they go, oh, look, in addition, don't forget the control. More people got better who got the skin cream than who didn't, right? And that's still wrong. I mean, maybe sometimes you'll get the right answer that way. But what you're failing to do is make use of all the information necessary to make a correlation. That's why I put in a 2x2 contingency table, right? Because you have to look at the ratio of the positive to the negative outcomes conditional on whether you got treated or not. And what you can see, you're 3 times more likely to get better if you got the skin cream, but you're 5 times more likely to get better if you didn't. So it actually is more likely to make you get worse than get better. And we want to manipulate what the right answer is by changing the heading on the column, right? And what we do, we look at this is the raw data. Basically, those are smooth lines that reflect the proportion of the people who are getting the answer right or wrong. and we've arrayed them with respect to their numeracy. And numeracy it's not just an ability to do math. I mean, if you don't know any math, you probably won't be numerate. But you can still know a lot and not be high in numeracy, because numeracy is a critical reasoning disposition. That means that you know how to make appropriate use of information in quantitative form, and reliably will draw the right kinds of causal inferences from them. And not surprisingly, you know, that when people are low or modest in numeracy, they get exactly the wrong answer. People are more high, but really they have to get pretty high to get the right answer, right? Almost up at the 90th percentile. Okay, well, that's good. That's the way it's supposed to work. Oh, but let's do another version of the experiment where this time it's the same numbers, but this time those scientists, they want to know whether if you ban people from carrying concealed weapons, does crime go up or does it maybe go down, right? And we use the same numbers and we do the same manipulation of the headings so that some people are seeing the information that if properly construed would suggest that crime's going up, and some are seeing it where if it's properly construed, it would say it's going down, but if it's improperly construed, heuristically, it's going to get the wrong answer, right? So we have essentially 4 conditions. Now, I showed you already what happens in the skin treatment, and here's what happens with the gun ban. Now, it's kind of the same story, but I guess what would you say? It's kind of noisy. Well, why isn't the effect as clear? Well, because that's motivated reasoning. That's cultural cognition at work. Here we're just going to use the right-left measure, right? And there's not that much difference in the numeracy scores of the 2 groups. But this is part of the fun of it. Well, I'm not taking it. It's not funny, but you see one argument people have, our group is more numerate than your group. Our group does better with cognitive reflection. Well, if that's true, you're in big trouble, because you see, people who are really high in numeracy, it doesn't matter what their political ideology is, they're getting the skin rash problem correct. But in the numeracy problem, those high numeracy people are getting it right if the evidence, if the information properly construed, right, supports the position that is associated with their political outlook. But they're doing no better than the low numeracy people when the information properly construed contradicts the position that's dominant in their group. The good news is you're not more numerate than the other group, because if you were, then you would just be even more subject to this kind of bias, right? And I don't know. See, isn't that cool? Now you believe me, right? Because I got a big table. Actually, people do this kind of crap. It's crap. I mean, you really shouldn't accept it. I mean, because, yeah, even you can understand it. I understand what this means, but I can't get the practical significance out of this. So, you know, it's up to me to try to help you to see. And to see what? To see, here I'm just showing you the raw data. Don't trust people who don't show you the facts, they just show you a model too. Because if, you know, most experiments, if they work, you ought to be able to see the result, see it. But then you should ask, should I trust my eyes, right? I'm gonna apply a statistical model to discipline the inference. But then I should be able to help you see, well, what does the model say? So, I don't know, try this. You know, this is a simulation. I basically have a Monte Carlo simulation. It's taking the parameters in that model. It's estimating the influences of the cultural outlooks conditional on what treatment you were in and which problem you were in, right? And you could just, you know, compute the numbers. But it's computing them 1,000 times. And it's kind of doing it with a little shaky hand, you know, it's tossing in a little random error that corresponds to the precision of the parameter estimates. It does this enough time, basically 1,000 times, it covers the entire probability distribution associated with that estimate. I want to know. I say, hey, tell me, what would happen if I interviewed 1,000 liberal people who were low in numeracy? What would they say about the skin problem? Right? And then 1,000 people who were Republican, and, you know, they'd be about right here, right? You can see from the probability distribution. You know, they're distributed like that, and then the peak is the mean. They're pretty clumped together, and they're not doing very well. And these guys, you know, simulate what the more high numerate partisans are like, and they're pretty clumped together and doing a lot better on the skin. That's exactly what I said, and now you can see, too, that the raw data, you know, it's holding up when we kind of test it by saying, well, that's true. This kind of model ought to fit, right? Now we look at the gun ban, and you can see there's polarization. But one of the things you can see that's interesting about this, the gaps between the respective groups of partisans, they're smaller for the low numeracy than for the high numeracy. Right? The people who in the crime decrease condition, they were less likely to form divergent answers. They're both likely to be wrong if they're low numeracy, but very divergent if they're high numeracy. Same thing for the other condition, right? Crime increases. Right? Oh, what's going on here? I mean, these people aren't cheating because they're not just saying, I'm going to just go with the answer that supports my ideology. If they did, the people who are low in numeracy, they'd look like geniuses when they happen to be assigned to the condition where the information properly understood was consistent with their view. They just would have put that because they're partisan hacks. No, they're trying their best, and they don't think it supports their position then. But the high numeracy people, they know enough to figure out when that's true, and they don't miss it. Now, when it doesn't support their position, either they're lured away by the siren song, of that heuristic alternative because it sounds good now, it's singing your tribal hymn, or they're using their critical reasoning ability to basically spring loose a confabulatory escape hatch to the trap of logic, right? And if that's the way things work in the world, why would I think things work like that in the world? Well, because I see this in the world, and it was because I saw that I did an experiment. I wanted to know, is the reason that we see more polarization among people who are higher in science comprehension, and that measure combined the science literacy with some critical reasoning measures. I could have done the same thing with the cultural measures. These aren't different theories, they're just different ways to measure what the relevant motivating disposition is, right? And I can tell you why I prefer the other one if you like, right? But I'll see this. Right? This is motivated reasoning, the kind here with cultural cognition. You're construing all manner of information from, kind of logical arguments from scientists, or the experience, what do you feel with the temperature, or experience when your house is blown down, to actually using your faculty of critical inference to understand what the plausible causal mechanism could be when I'm showing you some data, right? Now, what to make of this? The first thing, you take a look at the science communication problem. I think it is defined, but not just by the polarization, but by the amplification of the disagreement, conditional on various indicia of critical reasoning. That's not normal, okay? I mean, this is normal with the fluoridation in the water, right? Just a nice bunch of pretty colors, no correlation, and the groups, they're not splitting apart, they're actually converging on it's not dangerous, right? This is normal. Same thing for medical x-rays. The number of issues that display the science communication pathology or pattern relative to issues that admit of investigation by decision science that don't, right, is tiny, right? Orders of magnitude more issues that look normal like that. And why is it, you see? It's not because people understand. The X-ray scientists, why don't the science communication people learn some lessons from them? They must be explaining it really well. People don't understand this. They don't know that 50% of the people will say that, in the true-false question in the United States, less in Britain, that the antibiotics will kill the virus as well as bacteria. Actually, it's even higher in UK. It's not a horrible question. Some people say, oh yeah, it must kill viruses too. Half the people are getting it wrong. But they're, it doesn't matter. You don't have to have a medical degree. You just have to know, you go to the doctor and do what she says. Take this medicine. Right? How'd you figure that out? This. You see, this is not a bias. People have to accept as known by science much, much more than they could ever hope to comprehend on their own, much less verify for themselves. That's true even for scientists. What they're good at is recognizing who knows what about what. And they're really amazingly good at it. And if they weren't, we wouldn't have science. We would never be smarter than the smartest person, because we'd never build on anything, right? And people tend to exercise this faculty inside of groups of people who are like them. I mean, they like them, they hang out with them, so they get more information from them, but they also like them, you know, and so they don't fight with them. I'm going to ask them what's going on. I'm getting an argument with this other person. They also can read the people who are more like them better. They know who's a poser, you know, who's telling them the truth. So they're going to basically form their views inside of these affinity groups, measured in some way. This is one approximation of it. And you know what? That's not a problem, because science comprehension is a culturally random variable. It's distributed across all of the groups in the same way. There are plenty of people in all the groups who know what's going on, and they all must have intact mechanisms for transmitting the information to their members, because if there was a group out there that consistently misled its members about what's known to science on things that are critical to their well-being, that group would be dead. Right? So it's okay that we have this kind of insular thing going on, or at least, you know, it's not preventing this, the normal. It's not normally distributed, but there's no, it's skewed to the left for all four of the groups on whether the X-rays are dangerous, you know, and you get that sloping, you know, the smart people are telling them what the answer is. I don't know. Actually, Republicans and Democrats, even the low numeracy ones, they'll have clear complexions. They must be being told by the ones who understand how to interpret the results, what's going on, right? This is pathological. Well, in the sense of being both unusual and bad. It happens when, for some reason, people's positions on some issue that admits of decision-relevant science gets entangled in antagonistic cultural meanings that transform them essentially into badges of group identity or group loyalty. Right? At that point, the stake that people have in forming positions that are consistent with their group will dominate the one they have in forming a position that's consistent with the best science. Because, you know, on something like climate change, it doesn't matter what you believe. You know, you don't matter enough individually as a consumer, a voter, an advocate, to have any difference. So make a mistake about the science, and nothing you do in any of those capacities will increase your risk or anybody else's. But make a mistake on that issue now, given what it signifies, and it could be very awkward for you. I'm not going to go back to New Haven with a sign that says it's a hoax, right? And if you live in South Carolina and you're the barber, you know, and you say, hey, or sign my polar bear petition, you'll be out of a job just like the Republican congressman who made that mistake was, despite being perfect on all of the other issues. So, you know, it makes sense, doesn't it? It's rational in that sense to attend to information in a way that will reliably connect you to your group. You don't have to be that smart to do it, but if you are really smart, guess what? You have a resource, an ability to understand information, argue back with it, that'll help you to do an even better job. You'll be an even better indicator of what people like you think. And that's rational, but it's also collectively disastrous, because if everybody's doing that, you see at the same time, then a pluralistic democratic community is less likely to converge, or converge as quickly as it should, on information that might be critical to all of them. And guess what? That doesn't change the incentive, as it were, for any individual to do otherwise. That's why it's a polluted science communication environment, these meanings, right? They're interfering, you know, with the normal faculties that people use to apprehend what's going on. And it's not, there's a kind of tragic conflict between the collective interest in people processing information this way and their individual interest in processing information in a way that doesn't reliably connect them to the truth. Those meanings are the pollution, right? And so what do? Well, there's not enough time, or is it 5 minutes? You put up signs that say, coconuts kill more people than sharks, if that's your call. What do you? Well, you protect the science communication environment, right? I mean, you look for ways of removing the entanglements between identity and positions on these issues if you can, so that there won't be an incentive to form views that are not truth congruent, but are identity congruent. Make the meanings consistent with everybody. I could talk a little bit about that. But the most important thing is avoid this happening. Right? The same methods that I'm talking about here that I've used to explain what's going on, they can be used to predict that something like this could happen. Right? And you can then take action. And just quickly, you know, we had the HPV vaccine. The CDC recommended it be given to the girls before they entered middle school to protect them from the sexually transmitted disease that causes cancer. Oh, and there was a big fight between Republicans and Democrats. It was very civilized, though, and stuck to the facts. And here's what it looks like. Only one state, Virginia, because Merck, the company that makes the vaccine, gave billions of dollars, actually has the law that says that the girls have to have the vaccine, and the others all rejected it. And you say, oh, it's obvious, because that's entangled in meanings relating to gender roles and parental autonomy. Well, yeah, but it didn't have to be, you see, because the Hpv vaccine for hepatitis B treats a sexually transmitted disease, right? It was recommended to be given universally to middle school kids, and all the states, they just added them to the books. And during the years in which the HPV controversy was tearing legislatures apart, the vaccination rate for HBV was consistently above 90%, which is our public health threshold. Same thing we had for all the other vaccines. Now it's 13% on the HPV. So what you want to say is, don't just look at the pathologies. Don't just select on the dependent variable. Look at the cases where something doesn't happen. What's the difference, right? Well, Merck, they wanted to get the vaccine out there quickly, so they got a fast tracking, which had to be for girls only, because only the girls would get cancer. It only could be measured anyway. They also then had a legislative campaign, get the state legislatures to enact these mandates, right? And they did all of this. Well, that's how people learned about the HPV vaccine from a political debate, right? And they didn't have to do this. If they hadn't had the fast tracking, it would have been approved in 3 years for boys and girls, right? And if they hadn't had the legislative mandates, it would have been covered universally by insurance. But also, if they hadn't had state legislative action, then what would have happened with HPV vaccine is what would happen with all the other vaccines, including the HBV vaccine. State health administrators who aren't political officials just would have got in the mail the notice and said, oh, why don't we have that, right? And when they would have, people learned about the HBV vaccine, that would have been good for the country. It wasn't good for Merck, you see, because they're in a race with SmithKline to get control of the market first. But you see, they put us at risk because people learned this way instead of this way. You would learn from your doctor who would say, I'm going to jab Jimmy or Jane with this, and this time has HPV. I don't care, I'm late for, we call it soccer practice or whatever. You trust your doctor. You would use your critical reasoning ability. Who knows what about what? And that sounds like a story. Guess what? We study. We basically simulate this. People will disagree about the HPV vaccine, but they'll go with what the expert says. But if they observe people like them arguing, right, then it'll cause cultural polarization. That's exactly the strategy that Merck happened to follow. And this isn't even 20/20 hindsight. People warned about this at the time, right? Gee, some people even studied it as it was happening and said, don't do this, you see, because you're polluting the science community. There's a risk of it. And the arguments weren't rejected. They just weren't even considered because there's no mechanism in the process for introducing this important asset into society, science, decision-relevant science, for thinking about what the science communication impact is of the regulatory process. So you see, you can blame the evil corporations or the zealots, you see, but that you're not getting the point. You should, if this happens again, it's our fault. Right? Because here's the polluted science communication environment. It's caused not by people being too stupid. It's caused not by people being super partisan zealots, right? And being unreasonable to each other. It's caused by our pluralism, which happens to be the same thing that makes us so damn smart. Popper knows that you can't have science flourish with its distinctive method of conjecture and refutation unless you're in the open society where bureaucracy won't get in the way of science, but people will develop the habits of mind that are necessary for contesting and exchanging the ideas. But you see what happens then is, how are they going to know? How are they going to know what the truth is? They have to take somebody's word for it. It's not nullius in verba, despite what the Royal Society says. nobody can tell them because it's the open society, but there are all of these certifiers, and that's okay. But they will sometimes, even just mathematics, so much known by science, this will happen by accident and misadventure, and also could be made worse by strategic behavior. But the treatment for that is to use our reason, right? And to combine the knowledge we have of these processes with the knowledge we have about how people can live their lives better, right? So that we can protect our knowledge and also our pluralism, right? We use our reason and we do the things that you're doing here to have a science of science communication that's dedicated to an important kind of science. It's a political science. How can we be an enlightened democracy, right, that is able to reconcile what allows it to know so much, with the pluralism of people and the challenges that creates for certifying what's known, right? That's a challenge, not a contradiction, and you can solve it as you're doing here. So that's it. Oh, do I have time to just find one more experiment? Or, well, no, I'll stop now. So.